Pre-calculus. Today we're going to look at how to solve equations with fraction powers or rational powers. The steps are going to look very similar to when we did the radical equations. First, I need you to isolate the term with the fractional power on one side of the equation. Get the term with the fraction power by itself. Number two, either turn the fraction power into a radical and then just continue the process that I taught you earlier. Or you could raise both sides of the equation to the fractional power that will cause that fraction to go away. And by that I mean if it becomes like a whole number, then you are good to go. I'll give you an example of that in a minute. Number three, step 3 is to solve the remaining equation for the variable, and step 4 is to check your answer in the rational power equation to see if it works. Isolate, figure out a way to get rid of the fraction power mathematically. Third, solve the remaining equation for the variable. And 4, you must check these answers to see if they work. Okay, example 1, we have 2n minus 8 quantity, notice the parentheses around all of it, and it's raised to the 1/4 power plus 1 is equal to 3. First step is to isolate this term, isolate that binomial. So your job is to, looks like, transpose the 1. Okay, when you do that, you're going to be left with 2n minus 8 raised to the 1/4 power is equal to 2. Okay, now you notice that on the left side of the equation, the fractional power term is isolated. So the next step is for you to either turn this into a radical using the rule from the last section. And remember, when it's a fraction, you take the numerator and it stays as a power on the base, so all of this would be a base. And then the 4, the denominator of the fraction, will become the index number. If you choose to do that, you can follow the same steps you did in the last section. So we're going to try that first. And then I'll model to you the other option you have. So it could be the 4th root of 2n, let me put this in parentheses, 2n minus 8. It's a good idea for you to remember to use parentheses there. And then when you get to that step, you've changed the fraction power into a radical. Then you are ready to follow the other steps from the past. If it's a 4th root, you're allowed to raise both sides of the equation to the 4th power. Okay, that's going to leave you with 2n minus 8 is equal to 16. And then notice that the radical and the fraction power is gone, so the next step is just to solve for n, solve the remaining equation. It is a linear equation, power of 1, so you would expect one answer. I'm going to transpose the negative 8, make it positive. You're going to add 16 and 8 to get 24, and then you're going to just divide by 2. And so n is going to be equal to 12. Okay, so we got 12. When we check it, just to kind of review from the past, you can check it in any radical or fraction power equation you have. So that step, this step, or this step. Or actually, even this one. That's your choice. Okay, so we'll do a check to the side. I'm going to do the 2 times 12 is this solution that we got, minus 8. Raise it to the 1/4 power, which again is this 4th root. and then equals 2. And so I just use this one. Alright, next step. 2 times 12 is 24. 24 minus 8 is 16. Raised to the 1/4 equals 2. And so you can use your calculator on that. 16 to the 1/4 power is the 4th root of 16, which is 2. And since 2 obviously equals itself, then this is just the check showing that my answer down here is correct. So 12 is the solution. Just be really careful where the fraction power is placed, and really pay attention to parentheses. So if you see those, that 1/4, remember, is on everything. So this entire 2n minus 8 goes underneath the radicand, or underneath the radical. Okay, check out number 2. We have 4x to the 3/2 minus 6 is equal to 494. Okay, notice, back to my last comment, this problem I don't see parentheses. So the 3/2 is actually the power only on x. 4 is raised to the 1st power. So that is going to make a difference in how you see that problem. So you're going to transpose first. So you're going to call this 4x to the 3/2 is equal to 494 plus 6. Okay, that's going to lead to 4x to the 3/2 is equal to 500. You're going to divide by 4 on both sides. Remember, we're trying to isolate the fraction power, and since 4 is not in parentheses with the x, that's how you'll have to show that. You're going to get rid of the 4 by dividing. So those parentheses are really, really important, and you got to know what that means. Divide 500 by 4, you get 125. And so this is where I am right now. And I can turn it into a radical if I want. Let's see, that would be the square root of x to the 3rd. Square root of x to the 3rd. Is equal to 125. And then from here, remember, you take the numerator and leave it on your base, and you take the denominator of the fraction, and that becomes the index number, which is here. And so if you're going radical, using the radical method, then you're going to raise both sides of the equation to the inverse of square root, which is squaring. So you'll show that step. And that's going to leave you with x to the 3rd is equal to 125 squared is 15,625. There we go. Get rid of this. And then at that point, you still don't have x by itself, so now you're going to have to do the opposite of cubing, which is taking the cube root on both sides. And then x will be by itself. So now we need the cube root of 15,625. And that should be 25. Okay, so that's what I think the answer is. So now we're going to go over here and we're going to do a quick check. You can use the first step, the second step, the third step. You can even use this one, and you can use the one with the cube root. Switch it up this time and do the square root. I said cube root, I meant square root there. And so the square root of x is 25, we think. We're going to cube it. And set it equal to 125 and see if it works. So 25 cubed, we're back to where we started. It's just making sure we complete the process here. 15,625. We're trying to see if the square root of that number is 125. And let's see. And it is. Alright, there we go. Okay, so the check works, and that is showing me that 25 is the solution. Again, please pay attention to where the fraction power is placed. It's only on the x. So if you're thinking about it in terms of a radical, because I forgot to show you that on the last problem, if you want to instead turn it into a radical up front, then you would have to see this as 4 is the coefficient, and then this term becomes the square root of x to the third. And then there's a minus 6, and then equals 494. And so I could have given you this problem in the last section. So really the only difference is trying to get you used to how you turn the fraction into a radical, and to see that you really can follow the same rules. And so but pay attention to the 4, because if you put it underneath, then you will not get the right answer. Alright, now compare that to the third example. This time I have a 2 in front being multiplied by the quantity 3x. It's raised to the 5/3 power, and it's equal to 2. And so I'm going to first try to isolate the fraction power, that term, and we're going to do that by getting rid of the 2. So I'm going to have to divide both sides by 2. And that's going to give me 3x raised to the 5/3. And that's equal to 1. Now, because the 3 and the x are both included with this fraction power, if I'm thinking of it in terms of a radical, then I can write it as the cube root of parentheses quantity 3x raised to the 5th, and set it equal to 1, like that. Another option you have is, I'm going to rewrite this over to the side because I haven't shared this with you yet. You don't always have to turn it into a radical. You can do what the first slide said, and you can try to figure out what fraction power you can raise each side to get this 5/3 to go away. And what will always work, go to the side here, I'm dealing with 5/3 in this example, but I'm trying to figure out what fraction I can multiply that by so that it becomes a whole number. And so I'm just going to stick with 1. I mean, you can use any whole number you want, but 1's going to be the easiest to solve for because we want x by itself anyway. We want the power on x to be 1, basically. So 5/3 times something is 1. And so this is nothing other than just a multiplicative inverse, and that is a fancy way of saying in multiplication, we want to know what fraction we can write here and multiply it by the original to basically get 1 back. And so the inverse is the same thing as reciprocal. You learned that word early on in math. And reciprocal means just flip the fraction upside down. So if they give you 5/3, you're allowed to use 3/5. and it will work this way. This is just another option. You can put 3/5 here. Make sure you put parentheses around all of it. And then whatever you raise to the left side of the equation, you can need to do the same thing on the right side. So right now it's a kind of a preference if you want to do the radical form or if you want to do this form. But I do want you to know both because sometimes this form is actually faster and will lead you to the answer quicker. So I'm going to continue this side for right now just to show you why that I feel like this might be faster here. When you multiply 5/3 times 3/5, that is 1. So this entire left side is going to go to 3x. I'm going to keep it in parentheses just for the sake of it. But 5/3 times 3/5 is power of 1. And then on the right side, 1 to the 3/5 power, well, 1 to any power is just going to be 1. And so I don't have a radical now. I do not have a fraction power, so I'm basically just dealing with a linear equation. 3x is equal to 1. And then all I have to do now is solve for x by dividing by 3. And so that means x is equal to 1/3. That's pretty easy. That's probably faster. Over here, if I choose to go the radical route, then I have to get rid of the cube root. So I'm going to have to do this first. This might take a couple more steps. And then that means I'm left with 3x as a quantity raised to the 5th power equal to 1 to the 3rd is 1. Well, I don't have my variable by itself. It's actually raised to the 5th power as well as the 3. So now I have to undo the 5th power, which is the opposite is taking the 5th root. So now I have to do another radical. But I have to do it on both sides. We treat both sides the same. And now the 5th root of something to the 5th power is that something back. And so the radicand is what's left. And the 5th root of 1, what times itself 5 times is 1? It's just 1. And now you can see that it's equivalent. Just a different method to get to the answer. So it really depends on you, like what you're more comfortable with. But I do want you to know both methods and be able to efficiently use them. And then the last thing I'll do, again, is check your answer. So you'll have to go back and pick one of these fractional powers or radical equations and see what happens. So let's finish that out. And then I'm going to let you try some on your own. So I'm going to stick it in the parentheses 3x. Let's see. I'm going to use this one for right now, okay? So it's 3, and then we think the answer is 1/3. And then it's supposed to be raised to the 5/5. No, 5/3. Sorry about that. And it's equal to 1. And we're just trying to see, does this work? Well, we do inside the parentheses first. 3 times 1/3. That's just going to be 1. And now we are left with 1 to the 5/3 power. And 1 to the any power is 1. And so it just shows that it does work. So 1/3 is a good answer. And so I've shared 3 examples with you, and by coincidence, all 3 of mine had worked in the check. Sometimes they don't, though, and you do need to make sure that you show that in the process of solving the problem. Okay, so I want you to give it a try following the steps that I shared with you and your examples.